Alright, so today in class we learned how to do combustion reaction analysis. We reviewed combustion today and then we went through a couple of practice problems. So let's look at example number 2. I did example number 1 in class as well, but just to kind of walk you through step by step so you can re-watch this over and over again, I'm going to do example 2 because this one actually wants you to go over the molecular formula as well. So to read the problem, it says caproic acid, which is responsible for foul-smelling socks, is composed of carbon, hydrogen, and oxygen, but we don't know what the ratio is. So combustion of 0.255 grams of this compound produces 0.512 grams of carbon dioxide and 0.209 grams of H2O. So we need to, first of all, A, find its empirical formula, and B, we have to use the molar mass to decide if the empirical formula is what we have or if we have a molecular formula. So right off the bat, I want us to write a chemical equation. So we don't know what the ratio of carbon, hydrogen, and oxygen is, so I'm actually just going to write CX. I'm going to write CXHYOZ because we don't know. And it is going to be added with oxygen because this is a combustion reaction to produce CO2 and H2O. Okay, so now we have to try to figure out how to go about figuring out the empirical formula. Because if you remember from the empirical formula, we have to know the moles of our individual elements, and then we have to do a mole ratio. Well, it didn't tell us any information about our individual elements, so we kind of have to do it in a roundabout way. So first of all, I want to kind of show you one thing. As carbon breaks down, all of it is broken down into carbon dioxide. And as hydrogen is broken down, all of it is broken down into water. So this kind of gives us a starting off point because it told us the grams of carbon dioxide and the grams of water that are created. So we can kind of work backwards from that to determine carbon and hydrogen. However, oxygen is broken down but into two different compounds, so that one's a little bit harder. So what we're going to do is we're going to try to figure out carbon and hydrogen, and then from that do easy math to figure out oxygen. So step 1 is we are going to try to convert grams of carbon dioxide into grams of carbon. So for carbon, first step, we're going to write down 0.512 grams of carbon dioxide, and we are going to try to convert this into carbon. So to do this, first of all, we have to go to moles. So 1 mole of CO2 has a mass of 44.01 grams. We don't want moles of carbon dioxide, we want moles of carbon. However, we don't have a balanced chemical equation, so we can't do a mole ratio. So to do this, we're just going to look at carbon dioxide itself. In carbon dioxide, we only have 1 carbon, so we're going to say 1 mole of carbon for every 1 mole of carbon dioxide. But again, we can't stop at moles. We have to keep going into grams because we need to figure out how much mass of oxygen we have, and that's the only way we can do it. So the next step is to go from moles to grams. So in 1 mole of carbon, we have 12.01 grams of carbon. So if you do 0.515 divided by 0.44 times 12, we should get an answer of 0.140 grams of carbon. So now we know how much carbon we have. So now we need to figure out how much hydrogen we have. To figure out how much hydrogen we have, we're going to do the exact same thing. It told us how much water we ended up with, and since all of our hydrogen was converted into water, conservation of mass, it should be the same. So if we take 0.209 grams of water, we are then going to have to first convert it to moles. So 1 mole of water is going to have a mass of 18.02 grams. Okay, but we don't want moles of water, we want moles of hydrogen. So doing the same thing we did with carbon dioxide. There are 2 hydrogens in water, so this time we're going to have 2 moles of hydrogen for every 1 mole of H2O. Now, I'm sure some of you are going right now, but wait a second, isn't that H2, not H? Well, normally, yes, we would put H2, but this isn't a diatomic molecule because we know that hydrogen is in a compound, so we're just going to treat it all by itself. We're not going to treat it in a pair of two because it's not all by itself. It's part of a compound. Our next step is to convert it into grams. So 1 mole of hydrogen is going to have 1.01 grams of hydrogen. So if we do this math, we should get an amount of 0.0234 grams of hydrogen. Okay, so we should have just found that hydrogen should have had a mass of 0.0234 grams. So now let's try to go on and try to figure out oxygen. We don't know what oxygen because oxygen was in two different compounds. So what we're going to do is we're just going to subtract. We know that the mass of the original compound was 2.255. Well, we didn't lose any mass. So if we know how much carbon and hydrogen we have, we should be able to figure out how much oxygen we have. So we're going to take 0.255, subtract it by our carbon, which was 0.140, and subtract it by our hydrogen, which was 0.0234. And from all this, we should get that our oxygen equals 0.0916 grams. Okay, but that's not getting us really any closer to figuring out our empirical formula, because in order to figure our empirical formula out, we have to do a mole ratio. So, but now that we have our grams, we can convert to moles really quickly. So, for carbon, hydrogen, oxygen, we found that our carbon was 0.140. So to convert it into moles, we're going to do 1 mole over 12.01 grams. For hydrogen, we found our answer to be 0.0234 grams. To convert it to moles, we're going to do 1 mole over 1.01 grams. And then for oxygen, we found it to be 0.0916 grams, and we have to convert it to moles as well. So 1 mole of oxygen is 16 grams. So now let's do the math. So if you do the math for carbon, you should get an answer of 0.0117. For this one, you should get an answer of 0.0232. And for oxygen, we should get 0.00573. Now, to figure out the next part, we have to find our smallest mole amount. So if we look at the 3 moles amount, we see that oxygen is the smallest. So what we are going to do is we are going to divide each one of these by our smallest. So if you take 0.0117 and divide it by 0.00573, we get an answer of 2. If you take 0.0232 and divide it by 0.00573, we get 4. And if you take 0.00573 and divide it by itself, we get 1. So we have found that carbon has a ratio of 2, hydrogen has a ratio of 4, and oxygen has a ratio of 1. So that means that our empirical formula is C2H4O. So there is step A. A was wanting us to find the empirical formula. Now B wants us to say, okay, so this is our empirical formula, so what is our molecular formula? Well, the problem told us that its molar mass was 132 grams per mole. So before we can do anything, we have to figure out the empirical formula's molar mass. So if we take carbon plus 4 hydrogens plus 1 oxygen, we find that the molar mass is 44.06. So in order to compare it to the molar mass the problem gave us of 132, we're going to take 132 divided by 44.06, and we are going to get 3, which means that no, our molecular and our empirical formulas are not the same. Our molecular formula should be 3 times that of our empirical, which means that my molecular formula is going to be C, 2 times 3 is 6, H, 4 times 3 is 12, and O, 3. So our empirical formula is C2H4O, and our molecular formula is C6H12O3.